Imagine a time before time. Imagine a place before space. There was nothing. And then there was everything. In an instant, a single point of unimaginable energy burst forth. This was the Big Bang. It was not an explosion in space, but an explosion of space itself. This was the birth of our universe, a moment of pure, brilliant light. All the matter and energy that would ever exist was created in this single, spectacular event. It was the ultimate beginning, a silent and yet deafening roar that set the cosmos into motion, a beginning from which everything we know and see would eventually emerge. This initial spark was incredibly hot and dense. It was a searing fireball of pure potential. The laws of physics as we know them were forged in this crucible. The fundamental forces that govern everything, from the fall of an apple to the orbit of a planet, were born in these first fractions of a second. This moment was the seed of all complexity. From this simple, elegant beginning, an entire universe of staggering beauty and complexity would grow. The energy was so intense, so concentrated, that it defied all earthly comparison. It was the brightest dawn imaginable, the first light shining into an existence it was simultaneously creating. Think of it as the universe taking its first breath, a breath of fire and light. This brilliant energy began to expand outwards with tremendous force. It carried with it the building blocks of everything. Tiny particles began to form from the cooling energy, the first whispers of matter. These were the protons and neutrons that would one day build stars, planets, and even you. The universe was a rapidly swelling balloon of glowing plasma, a sea of charged particles bathed in the afterglow of its own creation. It was a simple, uniform, and intensely beautiful state of being. This expansion was the most important event in cosmic history. It set the stage for everything that followed. Without this initial push, the universe would have remained a tiny hot point forever. Instead, it embarked on an incredible journey of growth and evolution. The energy from that first moment continues to travel across the cosmos today. It is a faint echo of creation, a whisper from the past that we can still detect. This cosmic microwave background radiation is the oldest light in the universe. It is a postcard from the very beginning, reminding us of our fiery origins and the incredible journey we are all a part of. From that single, explosive moment, the universe began its grand expansion. It has been growing ever since. But this is not like an object moving through empty space. Instead, the very fabric of space-time itself is stretching. Imagine a loaf of raisin bread rising in an oven. As the dough expands, every raisin moves farther away from every other raisin. The galaxies in our universe are like those raisins. They are not flying apart through space, but are being carried along by the expansion of space itself. Every point is moving away from every other point. This cosmic expansion is happening in every direction we look. From our vantage point on Earth, it appears as though all the distant galaxies are rushing away from us. But an observer in a faraway galaxy would see the exact same thing. They would see our Milky Way galaxy rushing away from them. There is no center to this expansion, or rather, everywhere is the center. It is a truly democratic process, a universal phenomenon that affects the entire cosmos. The vast distances between galaxies are getting larger with each passing moment, stretching the cosmic canvas wider and wider. This stretching of space has a profound effect on the light that travels through it. As light journeys across billions of years from distant galaxies, the space it travels through expands. This expansion stretches the light waves, making them longer and redder. We call this phenomenon redshift. It is the primary evidence we have for the expansion of the universe. By measuring the redshift of a galaxy, we can tell how fast it is moving away from us and how far away it is. It's like a cosmic speedometer, allowing us to map the motion and scale of our universe. The scale of this expansion is almost beyond human comprehension. The distances are immense. The nearest major galaxy, Andromeda, is over 2 million light-years away, and it is getting farther away from more distant galaxies every second. The universe is not just vast, it is dynamically vast. It is a place of constant motion and change on the grandest possible scale. This continuous stretching creates an ever larger stage for cosmic events to unfold, pushing the boundaries of the known universe farther into the unknown with every tick of the cosmic clock. It's a universe in perpetual motion. As the universe expanded and cooled, something remarkable began to happen. The simple, uniform sea of particles started to clump together. Gravity, The quietest but most persistent of the fundamental forces began to pull matter into vast, swirling clouds. These were the first cosmic structures, giant filaments of gas stretching across the void. Over millions of years, these clouds of hydrogen and helium grew denser and denser. They became the nurseries where the very first stars would be born, igniting the darkness with their brilliant, newly formed light. The simple universe was beginning to develop texture and complexity. Within these immense cosmic clouds, pockets of gas collapsed under their own weight. The pressure and temperature at their cores soared. Eventually, they became so hot that nuclear fusion began. A star was born. These first stars were giants, hundreds of times more massive than our own sun. They burned fiercely with a brilliant white and blue light. They lived fast and died young, exploding in spectacular supernovae. These explosions were incredibly important. They scattered heavier elements, forged in the hearts of these stars across the cosmos. Elements like carbon, oxygen, and iron, the very stuff of planets and life. These enriched clouds of gas and dust then formed new generations of stars and galaxies. Galaxies are vast cities of stars containing billions or even trillions of suns. They come in beautiful shapes and sizes. There are graceful spiral galaxies, like our own Milky Way, with sweeping arms of bright blue stars and glowing pink nebulae. There are giant elliptical galaxies, which are massive golden spheres of older, redder stars. And there are irregular galaxies, chaotic and beautiful in their disorganization. Each one is an island universe, a testament to the creative power of gravity. Looking out into the night sky, we see this cosmic tapestry in all its glory. We see countless points of light, each a distant sun. We see the faint milky band of our own galaxy stretching across the sky. Through telescopes, we can resolve the delicate structures of nebulae, clouds of gas illuminated by the stars within them. They glow with vibrant colors, the deep reds of hydrogen, the cool blues of oxygen, and the rich purples of interstellar dust. It is a universe painted with light and matter, a swirling, dynamic masterpiece of immense beauty and scale, constantly changing and evolving. We have learned so much about our universe. We have traced its history back to the first fractions of a second. We have mapped the positions of billions of galaxies. We have peered into the hearts of stellar nurseries and watched planets form around distant stars. Yet for all our knowledge, the universe remains a place of profound mystery. The more we learn, the more we realize how much we do not know. The vast majority of the universe appears to be made of dark matter and dark energy, mysterious substances that we cannot see and do not yet understand. What is the ultimate fate of the universe? Will it continue to expand forever, becoming colder and darker until the last star flickers out? Or could the expansion one day reverse, leading to a big crunch where everything collapses back into a single point? Or will it be torn apart by the accelerating expansion driven by dark energy? These are some of the biggest questions in all of science. The answers lie hidden in the future, waiting to be discovered. The universe is not just a story of the past. It is an ongoing narrative whose final chapter has not yet been written. This sense of mystery is what drives us forward. It is the fuel for curiosity. It is what inspires us to build bigger telescopes, to send probes to distant worlds, and to ponder the nature of existence itself. The universe is a laboratory of infinite possibilities. Out there among the billions of galaxies, could there be other worlds like ours? Could there be other forms of life looking up at their own night sky and asking the same questions we do? The sheer scale of the cosmos suggests that the possibilities are limitless. We are explorers on the shore of a vast cosmic ocean. So the next time you look up at the stars, remember the incredible journey you are on. You are living inside this expanding, evolving cosmos. You are made from the ashes of exploded stars. The light hitting your eyes has traveled across unimaginable distances to reach you. You are a part of a grand, unfolding story that began 13.8 billion years ago in a blaze of brilliant light. The universe is vast, beautiful, and filled with wonder. And the greatest wonder of all is that we are here, able to appreciate it. The journey of discovery has only just begun.